Okay, so in this video I want to talk to you guys about the difference between a neuron and a nerve, and I want to talk to you about the spinal cord and how messages are sent from your body to your brain and back using the spinal cord, as well as reflexes. So lots of things to talk about in this video. This is my little neuron. Okay, this is what a motor neuron looks like. When we talk about a single cell, it's a neuron. But when you say nerve, you're really talking about a bundle of cells. It's a whole bunch of neurons collectively together. So if you have only motor neurons, it's called a motor nerve. If it's only sensory neurons in that nerve, it's called a sensory nerve. And you can have a nerve that has some motor neurons that are going away from the brain and spinal cord, and some sensory neurons that are going to and from the spinal cord. So here's your spinal cord, and here's your brain up here, okay? Sensory nerves are going to be coming from your skin, your eyes, your ears, your tongue, your nose, for all of your senses. And sensory nerves only have neurons that are traveling in one direction, from the extremities of your body and to the spinal cord, or towards the brain. Those are sensory. And motor are only going from the spinal cord out to your muscles. So those would be motor nerves. Can you have nerves that have some sensory going in and some motor coming out? Yes. And so those are called mixed nerves. So nerves are bundles of cells. It's not just one neuron, it's a whole bunch of them. I don't know if you guys can hear my cat meowing in the background, but she is. So if we come down here, imagine if I take this person's body and I cut it in half, and I lay them down face down, and I look at a cross section of their spinal cord. So the spinal cord is running through their vertebrae. Okay, so there would be bone surrounding this, and there's also a layer of fluid that is surrounding this as well. It's called cerebral spinal fluid. So there's protection around the spinal cord. The spinal cord is very sensitive. In cross section, we're looking at the spinal cord from the back side. So this is the dorsal. This is a person, imagine laying face down. So this is on their back, and this is on their belly side. So when you receive sensory impulses, sensory means coming from outside of the body or other organs inside the body. It's receiving stimuli that your brain needs to understand what's happening. Okay, what's happening outside of your body, what's happening inside of your body. So your organs, your internal organs, your bloodstream, your skin, etc. is all receiving impulses, okay? So when sensory neurons come from your senses, they're going to enter the spinal cord from the back, okay? These two things are called dorsal roots or dorsal horns. On this side, these are ventral roots or ventral horns. So sensory neurons always go in your backside. If it's on one side of your body, it's going to come in this dorsal root, and if it's on this side of your body, it's going to come in this dorsal root. So you've got all the sensory, it's always coming into the back of your spine, and it's going to enter into one of these roots. These are your sensory neurons. Sensory neurons have an axon, or kind of a long dendrite, and then the cell body is sitting here, and then the axon enters into the dorsal root, okay? If you have a whole bunch of these cells lined up next to each other, there's kind of a bulge here, and this pathway is showing where the sensory neuron is coming, okay? What happens is there's a little bulge, okay? The bulge is where all the cell bodies of those neurons are collected. That's called the dorsal root ganglion. Can you guys hear my cat? She's hissing, they're fighting with each other. So this bulge is the dorsal root ganglion. When the sensory neuron brings a stimulus inside the spinal cord, it's going to transmit that impulse at a synapse to an interneuron, okay? And that interneuron can send a message up to the brain, and then the brain can send a message back down, another interneuron, and then it's going to leave the spinal cord from a motor neuron, okay? It's going to always follow this pathway. So it's going to go this way, and then around, and then out, okay? So you have your sensory neuron, an interneuron, which is in between, and then you have the motor neuron. A motor neuron will stimulate either a muscle or a gland. Okay, so this is what's going to allow for you to have a response. So what should happen here is that you say you step on a tack, okay, or you step on something sharp. There's my little tack. It's going to send a sensory impulse through a sensory neuron. It's going to enter your spinal cord. It's going to go to your brain. The brain's going to send a signal down, and it's going to stimulate that muscle to move so you don't remain stepping on that tack. So that is your response. How you respond to something is you receive the sensory impulse, you interpret what it is, and then you send a message back out. And if we look at what's happening in the spinal cord, it forms this pathway where it comes in, and then it goes up to the brain, and then a message comes back down, and it comes out. But that takes a while for that process to happen. When you are born, you actually have a bunch of pathways already created, so that every time you experience something new, a new connection between neurons happens. But you're actually born with pre-mapped out response arcs, okay? These are reflex arcs. So instead of having to go to your brain and then think about what's happening and then respond, there are certain things in our environment that we need to respond to very, very quickly without really thinking about it. And if we respond to something very quickly without thinking about it, that is called a reflex. There's all sorts of reflexes in your spinal cord. And so what a reflex is, it's actually a pathway called a reflex arc. Sometimes you'll see it called a reflex act, where you receive some sort of impulse, and instead of having your brain have to interpret it, it immediately jumps to an interneuron and immediately jumps to a motor neuron so that you can respond more quickly. Like the example with the tack. When you step on a tack, you don't really have that slow of a response. You have pain receptors, or sensory receptors, in your skin of your foot, and that sends the impulse up to your spinal cord, and instead of having to go all the way to your brain and come back, it just hops right over. It goes and it comes back and allows you to respond very quickly. So that's what a reflex is. We have all sorts of reflexes that we're born with. We're born with the ability to swallow. We can cough. Certain things are reflexes. This type of reflex where you step on something and like pull, or you touch something hot and you pull your hand away, those are called withdrawal reflexes. They're to protect your body. Or like if somebody throws a ball at your face and you flinch, or you move your head and you close your eyes, that's for protection. Those are reflexes, okay? So in a reflex arc, you're going to start with a stimulus. Whatever the stimulus is. It could be pain, it could be heat, whatever. And then from the stimulus, you're going to travel up a sensory neuron. So you have the sensory neuron. The stimulus actually is going to hit one part of the sensory neuron called the receptor. So technically, the receptor would be next. The receptor is what is picking up, like the beginning of that sensory neuron. That's your sensory receptor. Okay? And then it's going to travel up the sensory neuron, and then it's going to come over here. It's going to go past this bulge outside the back of the spinal cord, the dorsal root ganglion. So it's going to do that next. And then it's going to travel to an interneuron. And then it's going to travel to a motor neuron. And it's going to leave out the ventral root through the motor neuron to the muscle or gland. The muscle or gland is called the effector, because that is what's going to make the response happen. So you have some of these built-in pathways that happen so quickly. Is the message still going to your brain? Yes. But you don't realize what has happened until after you've already reacted. So if you've ever stepped on something or touched something hot, and you responded so quickly and you didn't realize what happened until afterwards, it's because it was a reflex that was happening and you thought about it later. So this is your pathway of the reflex arc. Reflex is just a short path that's predetermined at birth, And even some of them are before you're born, because your brain and spinal cord are forming almost completely before before you're born. It's predetermined and it's already lined out for you, and it doesn't have to go to the brain and then back down. So you're kind of bypassing the brain. Even though the message will eventually get there, you can start reacting first. So reflexes are really important. If you don't have reflexes, you would not survive in this world very long. And if you look at the PowerPoint that I sent, there's something similar to this, where it shows the spinal cord in cross-section, and it shows you the reflex arc. In the next video, I'm going to go over the answers to the worksheet that we were supposed to do together. So make sure you watch that, and then you complete the answers correctly. Okay? Let me know if you have any questions.